Good evening, everybody. We're gonna talk about non-neoplastic leukocyte disorders. Alright. So we're gonna start off with severe combined immune deficiency. So severe combined immune deficiency is a condition in which your B and your T lineages lymphocytes are down, decreased. So in immunology, we have what we call your humor-based immunity and your cellular-based immunity. Your cellular immunity and your humoral immunity. They are under your adaptive immunity. So your cellular immunity is basically your T cells, no? All T cells, your CD4, CD8, CD16. In your humoral immunity, that's where your B cells, primarily your plasma cells, no? And primarily, primarily, and more specifically, your antibodies come in. That's your humoral immunity. If you have if the word is combined immune deficiency, then both your cellular and your humoral immunity is down. So kato. So gamma chain deficiency or X-linked SCID is the most common form of SCID. The problem is you don't have a interleukin 2 receptor gene, no? So wala kay receptor for your interleukin 2. Thus, there will be no differentiation and survival for your B, T, and NK cells, no? So it's decreased imuhang cellular and humoral immunity. And patients become symptomatic between 3 to 6 months old because your mother, your maternal immunoglobulins, namely your IgG, can still pass through the placenta, no? When you're still a fetus, and it passes through the placenta, and it will protect you once you are born, because when you're still young, your immune system is still banga, no? It's still developing. You still don't have your adequate amounts of your immunoglobulins. And your cellular mga lymphocytes nimo, they're still not as mature as they need to be. So that's when your maternal immunoglobulins, namely your maternal IgG, comes in to protect you from most of the diseases, no? About infections rather. Remember your maternal IgG, because IgG, immunoglobulin G, especially the IG4, is the only one capable of passing through the placental barrier, no? Because it's quite small. Your IgM can't pass through because remember your IgM is a pentamer, it's quite big. So patients become symptomatic at 3 to 6 months old, no? And once they're diagnosed, before they were put into this what we call your bubble, mga bubble boy, and bubble girls, so that they don't get exposed to any type of bacteria. So kato. Apart from that, they don't have tonsils or lymph nodes because they don't have B and T lymphocytes, no? Because your B and T lymphocytes are found in your lymph nodes and tonsils. Circulating T and natural killer cells are absent. B cells are adequate in number but are dysfunctional. Remember, your humoral immunity is of course dependent to your B cells, but if your B cells are dysfunctional, then no antibodies will be created. An autosomal recessive form is 10 to 20% present, and there is an absent adenosine deaminase deficiency. Without this adenosine deaminase deficiency, build-up of waste products within the developing cells will occur, and then they will eventually die, especially in the precursor ng mga cells, no? Next is we have what we call your Wiskott-Aldrich syndrome, WAS. Simple lang kaya ni siyang Wiskott-Aldrich syndrome. It is a combined immunodeficiency, X-linked, and think of thrombocytopenia diretso, no? So there is a decreased WAS protein, and this WAS protein is important in your cytoskeletal remodeling, in your B and T cells, along with your monocytes and your neutrophils. But one thing to note about your Wiskott-Aldrich is thrombocytopenia. Kana lang yung thrombocytopenia. an immune deficiency syndrome with thrombocytopenia, you already think of WASP, no? And it is X-linked, meaning usually boys, no, get positive with this. So there is bleeding, immune deficiency syndrome, infection at the same time naga-bleed, no? So you already have a clue that it might be Wiskott-Aldrich syndrome, and it is WASP, no? WASP protein ang absent. Next, you have your chromosome 22q11 deletion syndromes. The most sikat here is your DiGeorge syndrome. You have what you call your fish-like appearance, no? Fish-like. You also have others na mga syndrome here. Your Kaylor, Princeton, and the Opitz, dominant Opitz. So, the thing here is catch-22, no? That's your mnemonics. You have your cardiac defect, abnormal face, no? Abnormal face. They describe it somewhat like a fish-like, no? Because you have your hypoplasia of auricles. It has like elven ears. Hooded eyelid ptosis. Ang important yan is your thymic hypoplasia. So your DiGeorge syndrome, you have a lack of T cells because your thymus is absent, no? If you have lack of T cells, then your cellular immunity is decreased, no? Because you don't have active T cells. But the problem with this, with catch-22, other organs are also associated with it. Your parathyroid, you even have problems with your kidneys, no? And your hypocalcemia because problems with your parathyroid pod. So, catch-22, that's your DiGeorge or your 22q11 syndromes. Fish face, thymus, aplasia. Wala kay thymus, no? You also have your Bruton tyrosine kinase deficiency, BTK. So your Bruton tyrosine kinase is an important enzyme that is needed to fully mature your B cells. Now, without this, immature or dysfunctional imong B cells, leading to no production of immunoglobulin. No, and if your B cells don't mature, don't become plasma cells, you don't have immunoglobulin, then it doesn't become plasma cells, then it will lead to decreased immunoglobulin, no? Wala kay antibodies, and if you don't have antibodies, it's more of a humoral naman na immune deficiency. So if your DiGeorge is cellular, then your Bruton is humoral deficiency, no? Because of the absence of your Bruton tyrosine kinase or your BTK. It's X-linked, no? So remember, DiGeorge 22q11, so that is now your chromosome. So 22, chromosome 22, no? So kana siya, meaning autosomal siya, somatic, and then your Bruton is X-linked, meaning sex-linked. So kato. Also have your Chiajak-Higashi. So you have the problem with your Chiajak-Higashi is your lysosomes, no? Your lysosomes, no, organelles, they tend to fuse together, no? So there is an absent protein, your CHS1 list, no, LYST. May tabuan na your lysosomes tend to fuse and they become these large granules, no? If they are large granules, especially in your granulocytes, not because they're large, meaning they're effective. They're quite, on the contrary, they're quite useless, no? So, because of this large lysosomes, they can't produce the appropriate phagocytosis or phagolysosome formation, leading to very poor immune response, leading to recurrent bacterial infection. So ideally, basically your cellular and your humoral immunity is fine. It's just that your mobilization of your phagocytes and the function of your phagocytes are really inadequate, no? So remember, phagocytosis is one of the cornerstones of a strong immune system. If you don't have good phagocytosis, then your immune system is already hamstrung. So, kani siya. Another thing is the presence of partial albinism. Basta Chiyakigashi, albino ni sila ha. So, pag di George, fish face, no? Katong more elven ears, hooded eyelids. Pag sa Chiyakigashi, albino. So, defects of respiratory burst. Your respiratory burst is the final nail in the coffin in your phagocytosis. Your respiratory burst is where your reactive oxygen species are being used as weapons against the invading bacteria in your phagolysosome. So, if you don't have an adequate respiratory burst, then you will have a very big problem. You will have lots of granulomas. What is granuloma? So, granuloma formation is what happens when a cell, a phagocyte, can't kill the bacteria that it has phagocytosed. What will happen is it will call for help. And when it comes call for help, other monocytes or macrophages try to cordon off the cell, the phagocyte that didn't kill the bacteria. It will try to cordon it off, blocking it. And that's what you call your granuloma formation. It's a cordoning off or a formation of large nodular structures of macrophages, or now what we call epithelioid cells, that try to isolate the bacteria. Because the bacteria will eventually kill the phagocyte because it's just gonna continue to multiply. So eventually, pag mawala na yung oxygen na makuha ang bacteria due to the cordoning off of the epithelioid cell, it's eventually gonna die. So that is now your gone complex in your TB. So in your chronic granulomatous disease, you can't the respiratory burst or your oxidative burst is absent because you have an enzyme, your NADPH oxidase, and then deficiency. You don't have NADPH deficiency, and then you can't produce your superoxide. One of the strongest na mga reactive oxygen species, strongest is hydrogen peroxide, but strong po ng superoxide. But you can't do your oxidative burst, Wala. So that's why you have granulomas. Not necessarily because of TB, but basically any bacteria or any type of pathogen that the phagocyte fails to kill due to the lack of phagocyte respiratory burst. So for us to know kaning if you have chronic granulomatous disease, we can actually do your tetrazolium nitro-blue na test, So your WHIM syndrome. WHIM. So WHIM is just basically warts, hypogammaglobulinemia, infection, and myocalithexis syndrome. Oh, yeah, sorry. Going back to your chronic granulomatous disease, it's the same as your Chiyakigashi. It's more of okay tanan imuhang detection, okay tanan imuhang cellular and humoral immunity. Just so happens the activity of your phagocyte is lacking. Kumbaga, So, next is your WHIM, warts, hypogammaglobulinemia, infections, and myocalithexis. So there is a problem with your CXCR4 gene. So your CXCR4 regulates the movement of your white blood cells between the bone marrow and the peripheral blood, And then meaning dili ma-transfer from the bone marrow to the peripheral blood imong neutrophils. So it's na-defeat ilang purpose, They're just gonna stay in your bone marrow, and that is what we call your myelocathexis, Meaning dili sila makaadto sa point of infection or inflammation because they have an abnormal CXCR4. And mind you, CXCR4 is another receptor. It's a co-receptor for your HIV na human immunodeficiency virus. So, morphologic abnormalities of leukocyte without associated immunodeficiency. So, it's just morphologic activities. They have normal to decreased immune response. So, Pelger-Hewitt anomaly, Pelger-Hewitt is characterized by, it's a congenital. The true Pelger-Hewitt is congenital. We also have your pseudo-Pelger-Hewitt. in your myelodysplastic syndromes na kana siya or acquired. So it will pellucidate, simply put, it has bilobe nuclei, or what we call your pince nez. Pince nez is the type of glasses that will pinch the nose. Itong kay Morpheus, ganun sa Matrix, kana siya. That's what you call your pince nez. So kana siya ang pinaka-klaro sa imong pellucidate. So it's really claro in your neutrophils. Next, we have your pseudo or acquired pellucidate. So that's, you find that in your myelodysplastic syndrome. We will talk about that next sem. No? Myelodysplastic syndrome, there is dysplasia in cell lines of your bone marrow. But the problem is, dili mo abot og 20% ang blasts, leading to diagnosis of MDS. If more than 20% ang blast, it has already leukemia. So, kato. Next is we have your neutrophil hypersegmentation. Anything that will hypersegment is automatically associated with megaloblastic anemia. So if there is hypersegmentation, there is overmaturation of your nucleus, no? And then usually problems in maturation brought about by lack of, in your megaloblastic anemia, it's usually by the lack of vitamin B12 or cobalamin or folate, no? So kana siya, hypersegmented neutrophils. So along with your kanang macroovalocytes over here. So usually the lobes of your neutrophils is just 3 to 5. It's more than 3 to 5, then it's already hypersegmented. If it's just 2, of course it's hyposegmented. No, that's now your bilobe pellucidate. Also have your May-Heglin anomaly. Your May-Heglin, kani, you see this? Pag May-Heglin, isa lang inyong huna-unaon, giant platelets, no? We also have your Dole bodies over here. Okay? Kana siya. And then your Alder-Riley anomaly. Your Alder-Riley anomaly is, it's a problem with kanang, we have your mucopolysaccharide na kanang, we are gonna talk about it later. So your Alder-Riley is a type of storage disease, meaning you have excess kanang excess na mga precursor na mga substances that is filling up your cells, no? So usually in your Alder-Riley, you see your metachromatic granules, no? So gargoylism is specific for Alder-Riley, but it's also seen in your Gaucher, your Hurler and Hunter, na mga your Hurler and Hunter syndrome, no? We will talk about that later. Your lysosomal storage diseases, basically it's an umbrella term, and then this one includes your sphingolipidosis, your Niemann-Pick, your oligosaccharidosis, your MPS, your mucopolysaccharidosis. So your mucopolysaccharidosis is a problem if you have an enzyme that is absent that will break down a specific substance to usable na mga compounds. If you have the enzyme missing, then buildup of the precursor substance will be present. So here, so if you have an enzyme that degrades heparan sulfate and it's absent, then there will be buildup of heparan sulfate usually in the liver cells, no, in the bone marrow, no. So what we call them Riley bodies, no, in your mucopolysaccharidosis. Next, you have your Gaucher disease. It's the most common lysosomal lipid storage disease. So, it's the absence of your glucocerebrosidase, and then there will be a buildup of your glucocerebroside, no, in your cells, no, especially your macrophages. Why is it that there will be buildup in your macrophages? Usually, manggod, your macrophages, they are the ones that eat this stuff, no. They eat this stuff because they're the ones in charge of cleaning excess, taking up excess stuff to break down. So, once they eat this, ang problem, example, na-cell din yun, tungod kay dagan kay siya glucocerebrosidase, so ay, ginakaon na siya sa macrophage. But ang problem, since the macrophage is also absent with the enzyme, your macrophage also gets big because of the increased glucocerebrosidase. Kaya wala siya pang breakdown ato. Dako po siya. No? So eventually bone marrow replacement by these Gaucher cells get contribute to anemia and thrombocytopenia. So that's what you call your myeloproliferative anemia. We call this kaning mga Gaucher cells, they replace your hematopoietic stem cells. So wala na kayo ma-produce na red blood cell and platelets. So Gaucher cells are exhibiting abundant fibrillar blue-gray na cytoplasm, sometimes what we call your onion scale-like. That's your Gaucher cells. Next is your Niemann-Pick disease. So your Niemann-Pick disease, kana siya, accumulation of sphingomyelin, no? So because you don't have the enzyme, your sphingomyelinase, wala ka na kita na enzyme. So mag-build up ang sphingomyelin over here, and then kato, it's blue. So this is your table for this So it's quite a short topic lang, guys, no? So I expect you to read the PowerPoint and also read the book kato. And if you have any questions, feel free to PM me, especially if pag-abot sa mga kato. Thank you, guys. Good night.